even though we went over this proof in class today, I realize that there's still a lot about this that feels new and that it might be useful for me to give it to you in one of these lectures that you can stop, pause, rewind, and go over as many times as you like. Because this stuff about indirect proof is important. So we're going to look once again at the proof that from P arrow Q, not P or Q follows. And it's an exercise in thinking about indirect proof. The first thing is this. We want to prove not P or Q. It's not a conditional, so there's no point in trying to do it by conditional proof. If we could prove not P, of course, we'd have it, but there's no reason to think we can do that. From P arrow Q, there's not the slightest reason to think that not P follows. Likewise, from P arrow Q, there's not the slightest reason to think that Q follows. So since nothing else is obvious, we do it indirectly. And that's a very good general point. When you're trying to prove something, if nothing else is obvious, never be afraid to try to do it indirectly. That's just what you always want to do. If you're stuck and you can't see any other way, go indirect. So this is an assumption for contradiction. This subproof will be complete when I get a contradiction on an available line, and then I can put in my scope lines and complete the proof. But now you might think, well, how does that help? Because I don't have any rule that lets me manipulate this in any useful way. I don't have anything I can apply to this to extract information. So it looks like I'm just stuck with two pieces that I don't know what to do with. Now we think strategically, however. In order to complete this proof, I need a contradiction. Any contradiction will do. That is to say, I've got to get on one line a sentence and not that sentence. So what I try to do is get a contradiction between something I've already got and something I might have a hope of proving. Well, trying to prove not bracket P arrow Q at this point sounds like it might work, and eventually it probably would, but it doesn't sound like it'd be easy. But suppose I could prove not P or Q. That would contradict its own denial, and I'd be through. Now that might seem crazy at first, because you might say, well, isn't that exactly what I'm trying to do? Why are you asking me to do what exactly I'm trying to do? But no, that's not it. I would be trying to show that given this premise and this assumption, I can prove not P or Q. But if I succeed in doing that, the assumption will then get put behind a wall. So I am going to try to prove not P or Q. I'm doing it for strategic reasons. It's because it contradicts this. But I'm going to think about how I might do that. I don't want to try to go indirect again. That would just amount to repeating the same assumption. Rather, at this point, maybe I could actually succeed in proving not P. I couldn't have just proved it here given what I had, but now I've got this and this. And notice, if I had not P, I'd be able to get somewhere. And I know that implicitly, this and this contradict themselves, contradict one another. So maybe at this point, with this extra assumption, I'll find a way to prove not P. But meanwhile, strategy. How will I try to prove not P? Notice, by the way, I'm doing this differently than we did in class, but that's fine. Well, once again, if I don't see any other way to proceed, I do it indirectly. Assume P, assumption for contradiction, and then I've got an indirect proof inside an indirect proof. So I'll have two assumptions to discharge, but bear with me. I've assumed P. If I succeed in getting a contradiction, I will have not P. If I get not P, I'll have not P or Q by addition. Then I'll have a contradiction. But I need a contradiction to complete this. So let's see what happens. You might think, I don't know what to do. The answer to the what to do question is this. At this point, try to extract information, because you can. I've got P arrow Q, I've got P, and so by modus ponens, I can get Q. From 1 and 3 modus ponens, I get Q. Now, when you did that at first, it may not have been obvious why you were doing it, but if you think about it, you can see something. If I've got Q here, I can get not P or Q. And if I do that, it'll contradict line 2. So go ahead and do that. I've got not P or Q from line 4 by addition. I did that because it gives me a contradiction with line 2, and it allows me to complete this innermost indirect proof. If I put line 2 together with line 5, I could write out the contradiction, bracket P or Q, close bracket, and not bracket P or Q, close bracket. But if you saw the other lecture, you remember that we have a shorthand way of representing contradictions like that. So that's what I'm going to do here. I'm going to write the perp, and I give the two available lines that contradict as the justification. Line 2 and line 5 contradict. This is just, in this context, a stand-in for writing out the full contradiction. Okay, so now I assume P, it led me to a contradiction. So the subproof is complete. And because I assume P to get a contradiction, what I have proved is not P. That is by 3 through 6 indirect derivation. Okay? I assumed P because I was trying to prove not P. I succeeded in doing that because I got a contradiction. So given my premise and this assumption, I can prove not P. So from my assumption and the premise not P follows, to complete the indirect proof I began on line 2, I need another contradiction. But now you can see what's going to happen. Now this is all going to look very funny, I agree, but remember that when you do what we're doing here, you're in different contexts. You're in the context of different sets of assumptions. Here the only assumption left in play is the one on line 2. But I can get a contradiction with it, because on line 8 I can get not P or Q from 7 by addition. Now you might think, well, why do that? You already had not P or Q on line 5. And that's true, I did. But it's now behind a scope line. And I had to put it behind a scope line. The rules of proof require it. And trust me, there's a reason for these rules. If we didn't write them the way we did, we'd be able to prove anything at all. So now, line 2 contradicts line 8. I have a contradiction that flowed from my original premise and my first assumption for contradiction. And so on line 9, I'm going to write once again the perp symbol, perp for perpendicular. The lines that contradict are what I cite. They are in this case 2 and 8. I have to say 8 because line 5 is not available. So they contradict. Line 2 led me to a contradiction. That means that this assumption has done its work. It can be discharged. And what I write on line 10 is not my assumption, but I remove the tilde. I get not P or Q. I assumed the denial of that to get a contradiction. I got the contradiction. What I'm left with is the thing itself, not P or Q. And that completes the proof. Now there's no doubt that this is a little bit involved. What I suggest you do, if necessary, is look at it a couple of times and then come back later and see if you can prove it without re-listening. Don't try to memorize it. Get it so that you can think your way through it, so that you feel comfortable at each stage about what you're doing. You're trying to develop a bunch of intellectual habits here, and this proof is a good way to do it. So I hope this is helpful, and in any case, if there are any questions, we can talk about it.